Okay, so today, April 5th, 2022, we covered writing expressions. So we'll just dive right into it. First, we started with the sum when we're dealing with math problems, and we mentioned the sum in an expression activity. We are referring to the process of addition. Specifically, if you're asked to translate a phrase into an expression, you use addition in parentheses. Same goes for difference. If the word difference appears, you will put that subtraction in parentheses. An example of this would be if a problem said that you are finding 1/2 of the sum of 2 and x, you would put 2 plus x in parentheses, and then you would multiply the whole thing by 1/2. Same goes for difference. And next is product. Now, product is multiplication. That has remained the same, but don't write the multiplication symbol when it is next to a variable. Let me show you what I mean. So the example would be 4 times n. So if I said find the product of 4 times n, we would use this option, 4n. This means 4 times n. That's what that means. And we know this because when we do substitution, let's say somebody came along and said that n equals 3. So assuming n equals 3, we would replace this. So it says 4, and we would replace that with 3 in parentheses. And we know that a number next to parentheses with no symbol between it means to multiply. So that is why we don't bother with the multiplication symbol. Side note, for multiplication symbols, this is a good symbol to use, an asterisk, just an X with a plus sign in it. A dot is also good, so like 2 times 2, this is what we would use. But you cannot use an X anymore. That is because an X at this stage in our math journey means a variable, not the product. Moving on from there, we have quotient. Quotient would be division, but we would want to write our quotient as a fraction. An example is if a problem says the quotient of 3 and a number, of course, being a variable that we don't know. We want to set it up as 3 over n, 3n, okay? This means 3 divided by n. We do not want to use our division symbol, not at this stage. The only 3 remaining terms that we're going to go over is squared. This means an exponent of 2. So that would be, for example, 5 squared would be that. And then the one afterwards would be 5 cubed, which is to the 3rd power, okay? And speaking of saying it to the 3rd power, we have more information down here. Let me just scroll this up a bit. The board is being a bit slow. So squared, exponent of 2, cubed, exponent of 3. And when we say to the power of blank, that means it's an exponent of blank. So if I said 2 to the power of 4, that would be 2 with an exponent of 4. Or if I said 3 to the power of 19, then the exponent would be 19. Okay? The next 3 things we took notes on are things called the properties. Now, these are the properties of addition and multiplication. That is to say that these will only work with an all addition and an all multiplication problem. This will never work for subtraction or division. Okay? Case in point, this is the associative property. The associative property, the super short version, is parentheses move, numbers stay the same. That's what that means. Now, in the case where it's all addition, we have 3 plus 4 plus 2. On the other side, 3 plus 4 plus 2. The difference is we have 4 and 2 in parentheses, which means we would do that first. And on this side, we have 3 and 4 in parentheses, which means we would do that first. But it doesn't matter, because 4 plus 2 would be 6, plus 3 would equal 9. And on this side, 3 plus 4 would equal 7, plus 2 equals 9. It doesn't matter what we do first, because it's the same thing. So, associative property, that's what that says. Commutative property. These are the same exact numbers, but a new order. Okay, so in this case, I have a multiplication set up. We have 3 times 4 times 2, which that would equal 24. And then on this side, I switched the 3 and the 2. and I moved the 4 over as well. So completely different order, but now it's also going to equal 24. That is what the commutative property states. It's that it's going to be the same numbers, just in a different order. And the last property we took notes on is something called the distributive property. Now, this has come up a lot in our warm-ups, so now we have taken official notes of it. And the distributive property states that we can multiply a number that is outside of the parentheses to everything inside. This is the only property that will have new numbers, okay? So on this side, we have a 5, 2, and a 3n. And on this side, we don't have the 5 anymore, we don't have the 2 anymore, we don't have the 3 anymore. That's because we've multiplied, okay? We have done 5 times 2, so 5 times 2, that's where this 10 came from. And we did 5 times 3 n's. So 5 times 3n would equal 15n, okay? That is how that is going to work. Now, just as a few examples, we did a few of them. The first 3 we kind of talked about, and these will cover pretty much everything. We've got m is added to 6. Well, this one's pretty easy. We would just add m and 6. So 6 plus m plus 6, they mean the same thing because the commutative property lets me put them in different orders. The second one, if you remember our notes from above, we have 1/6 of. Now, 1/6 of, this would be 1/6 times, okay? That's what this would be. And then on this part, we have the sum of d and 7. So the sum of d and 7, we've got d plus 7 in parentheses because it says the word sum. Then we just have to figure out, does it make more sense for the 1/6 to go in front, or does it make more sense for it to go at the back? And this setup is what we're looking for. We're looking for the 1/6 to go in front. The same kind of thing happens down here with number 3. We were trying to see, does 2/5 belong here, or does it belong here? Well, it doesn't look right like that because our multiplication symbol is now in the wrong place. So it makes more sense for the 3/5 to be on this side, okay? That is how we determine which one goes in place, all right? We do have, I think, just a couple of other examples. For example, what happens in the case of subtraction. Now, subtraction is different because order does matter a lot. We can see here, take away 4 from G. So we're taking something away from G. So we're doing G minus something. Or we could just say take away 4 would represent a minus 4. So we should have minus 4, not 4 minus G. This is backwards, okay? Just imagine what if G equaled 5. This would be 5 minus 4, and this would be 4 minus 5. Those do not equal the same thing. Order matters when it comes to subtraction. So this one, kind of a similar thing. We are subtracting 3/5 from 9 times C. So that means 9 times C, or 9C, should have been the first thing. And we're taking away 3/5 from it. 3/5 should be the second thing. Same thing happens in number 5. Subtract 2 from 7 times Y. That's how this whole thing is going to work as well. And that is what we covered today. This was a longer notes video, and these were kind of a lot of notes, but these should be the last notes that we need to take at the very least for this half of the unit. This is a very long unit, so we're not completely done, but this was the longest day of notes of the entire school year. There won't be another day of more notes than this. But that is it. Bye-bye.